Okay, so you can see some of the hot spots here. These are the Hawaiian volcanoes. The Hawaiian Islands are formed right here, and this is where the hot spots are. So we're going to look a little bit more as we look at the next one. So what are hotspot volcanoes? Hot mantle plumes. So this word plume might be unfamiliar to you. So we have the plume, which is right down here. So it's kind of similar to the magma chamber that many of you were looking at with your Volcano Cafe projects. Okay, so you have this area of magma that comes up and kind of makes like a bubble. Okay, and eventually what this bubble will do is it'll start to melt away at the oceanic crust and it'll get thinner. And as this gets thinner, you'll start having these eruptions in the middle of a crust, and then it will erupt and spew out basaltic lava. Okay, so the Hawaiian Islands are an example of the chain, hotspot volcanoes. So this is when some of that mantle material breaks through the crust and comes to the surface. Is basically what a hotspot volcano is. And hotspot volcanoes will happen in the middle of plates. So Hawaii is one. Can anybody name another one? To give you a hint, the Ranger was from here. Yes. Yellowstone. Okay, is also a hotspot. Okay, so the tectonic plate moves over a fixed hotspot, forming a volcano chain. So if here is your magma plume, you will have this magma rising and causing this like bubble. It'll eventually melt through, but as this crust moves to the left, that weak spot is going to move to the left as well, and then you'll end up with a new volcano forming over what is now the hot spot. So what happened is that millions of years ago, this volcano right here was in this position. Okay? And as the crust has moved to the left, you can see that these volcanoes, or seamounts as they're labeled here, tend to get a little bit smaller, and that's because of erosion. So like chemicals and water and wind and stuff like that breaking down the rocks that are there and making them flow back into the ocean. Okay? So as you get, the closer you are to the hot spot, the younger the volcanoes are. Okay, so Mauna Loa on Hawaii is still erupting today. So you know that it's a fairly young volcano. Whereas the volcanoes, the old seamounts that are way up near the Aleutian Islands in Alaska, are much, much older, like millions of years older. And scientists will use this progression of these volcanoes, this line of volcanoes, extinct volcanoes, as evidence for plate drift, so for continental drift. Okay? Okay, so we talked about how plate tectonics and volcanoes are related. Now we're going to talk about earthquakes. So this should also look familiar, similar to the map that I showed you online yesterday. You see all these volcanoes happening in like these lines, essentially. And those lines are actually your plate boundaries. So you guys all know that friction causes earthquakes to happen when the rock finally snaps. And here on the side it says the figure showing the distribution of earthquakes around the globe. Okay, so every single year there are tens of thousands of earthquakes. Anything that has less than a 3.0 magnitude will be not really able to be felt. So it's usually above a 4.0 that you might feel a minor shaking, but for each level that it goes up for magnitude, so from a 3 to a 4, it increases tenfold. So there's 10 times as much energy from a 4 magnitude earthquake than a 3. Okay, so is everybody caught up on their sheet? Okay, so yesterday when we were looking at those maps with all those earthquakes on it, we talked a little bit about how the further away from a subduction zone boundary you get, the deeper they get. So you might have some earthquakes down here. Okay, so if here's our boundary, so here's our subduction zone boundary. Okay, you'll have some fairly shallow ones, but then you'll have some really deep ones, depending upon how far that slab goes down into the astrosphere. Okay, so these are deep focused earthquakes here, but then you might also have them up here because of what's going on here. You know, this friction going on there. Okay, John, question? If you have, no, this won't really cause a tsunami. It's when they, it's usually if there's a shift up or down because the water's displaced to cause a tsunami. If it's just a transform, it'll probably just it might make some waves, but probably not a lot. View for the quiz. Okay, so here's just the summary, which I'll just leave up here for a few minutes. You do not necessarily need to copy this, but it is here for you to see if you want to look at it. So again, this will be on the video, because I'm recording it right now. So just keep that in mind. No, don't copy it.